this video, we will be talking about the ReLU activation function, which is the short for Rectified Linear Unit. So this is what a ReLU function is. It is the maximum of 0 and x. So let's see how it looks like. I've plotted it on my screen. It is basically the combination of an identity function and the function y equals 0. So it is the maximum among the identity function and the function y equals 0. Now let's look at a history of ReLU. It was suggested in 2010 in a research paper by these two researchers. They argued that the reason for unstable gradients in a neural network is due to the poor choice of activation functions. Now during that time, the two activation functions which are mostly being used were the sigmoid and the hyperbolic tangent functions. And due to the usage of those functions, uh, the problem that was uh, there was the exploding and the vanishing gradients problem. And the reason uh, the sigmoid and the hyperbolic tangent function suffered from this unstable gradients function, this unstable gradients problem, is that they are saturating activation functions. So let's plot them on our screen. Um, this is the sigmoid activation function, and let's copy it from here. And this is the hyperbolic tangent function. This line in blue is the hyperbolic tangent function. This line in black is the sigmoid activation function, and this line in purple or maroon is the ReLU function. Now, as it can be clearly seen that both the sigmoid activation function and the hyperbolic tangent function, they are saturating, which means that they saturate at a particular value. They never go beyond that value, which in this case is 1 for both of them. And it was due to this problem that uh, the unstable gradient problem was being caused, and therefore these two researchers, Glorot and Bengio, they suggested that we should use a non-saturating activation function such as a ReLU. Now the properties of ReLU. First, it is continuous at all points. As you can see, it doesn't break. There are no discontinuities in this function. It is differentiable at all points except 0. So at 0 you can see that there is a sharp edge in this function, which makes it indifferentiable at the point 0. It is one of the disadvantages of using this function. Okay, the next thing is that the ReLU function is monotonous. Monotonous means that uh, it never decreases. It is either monotonous means that either the function is always non-decreasing or always non-increasing. So ReLU is a non-decreasing function over the entire range from minus infinity to infinity. It never decreases. It stays constant from minus infinity to 0, and from 0 to infinity it increases. And the last property of ReLU is that it is fast and easy to compute. So as you can see that that ReLU function, it just computes the maximum of 0 and x. It is really fast. It does not have to deal with any of the exponential things which are used in the sigmoid or the hyperbolic activation function. Now let's come to the advantages of ReLU activation function. We've already discussed it. They do not suffer from the exploding and vanishing gradients problem. It performs better than traditional activation functions, which is the sigmoid and the hyperbolic tangent, especially in the hidden layers. And that is why in most of the neural networks, including CNNs and ANNs, they are used in the hidden layers. Fast and easy to calculate the value of the function, we have discussed it. And also it is fast and easy to calculate the derivative of the function. The derivative of the function is required during the backpropagation algorithm, during the backpass. Now obviously it has some disadvantages, and there are a few of them. First of all is that it suffers from the problem of dying ReLUs. Dying ReLUs is like the Achilles heel of this ReLU activation function, and there are many alternate of ReLU which overcome this problem, which we'll be discussing in further videos. And also it is not differentiable at the point zero, we have already discussed it. So that was it about the ReLU activation function. Hope you liked the video. Please do like, comment and subscribe on the channel. Personally it doesn't bother me much, but I need it for YouTube to rank my video. Thank you.